This face recognition module I showed, I found some more problem, one more problem in it. I'll show you that, and I'm actually working on it today. So, and one more thing, I resolved that GPU issue. I'll let you know how did I actually solve it. Okay, so first I'll show you GPU is working. Okay, to how to check that, and how to configure your system to make GPU work. Those two things I'll explain first, and then I'll show you the concept we understood and the implementation I did are not in sync in the Siamese network, especially the triplet loss function. So let me open one of these files. So I was actually writing my own, I was not using any pre-built model, but I just built my own code, right? CNN code to generate the 128 pixel. This is the module that actually generates the encoding. Using this encoding, we are actually doing this. This is not Siamese network basically, but we are actually trying to do a classification kind of a model where we are trying to generate these 128 vector uh, proper encoding of the original image. Okay, that's what we were trying. So it's not working. So I tried many different things and it's not working. Basically, you have to actually make it work as an exercise. So I already uploaded files, right? You can actually play with them, right? I ran it. Now I'll show you how to check whether the GPU is working or not. Okay, so NVIDIA SMI is the command, so which actually shows whether GPU is working or not. See this here, it is saying 3%, still loading it. Right? So now it started executing here, right? The model started training. Now if I execute the same command, see that 90%. Got it? So now my TensorFlow is using GPU. Okay, yesterday or maybe 1 week back I showed you, when I showed this was not, this is actually 3%, 1% kind of a thing. That time the model was not using the GPU, and see how fast it is. When it is executing on GPU, it is fast. I don't know whether you remember it or not. Yesterday it was actually slowly moving, right? Do you remember that? So now you know, right, how to actually check whether the GPU is being used or not while your training is happening, right? Whether your GPU is being used or not. On Colab, you cannot do this. On Colab, you cannot check this. But if you have your own machine, or in your real-time environment, if you got in your office you got a GPU machine, then you should be able to check this. NVIDIA SMI is the command to check. Okay, and to make the GPU work, what I did is I freshly installed total Ubuntu, and then went into this site, TensorFlow to GPU. See, this is the site, TensorFlow GPU support and TensorFlow. Right, in this, right? So install CUDA with apt. In Ubuntu there is a command called as apt, sudo apt install and all. Right, here they gave for Ubuntu 18 and Ubuntu 16 they gave. Don't install Ubuntu 20. The latest version is actually not working well, and there is not much support for the GPU based deep learning models, for the deep learning frameworks for 20. Okay, So install, if you are installing, right, dual boot, either do 16 or 18. 18 is better. So I just followed these instructions as it is, and then it started working. Okay. There is another caveat here. No, last time when I actually tried to follow the same instructions, last time in the sense 3 months back, it did not work. This time it worked. Right? That means, the deep learning frameworks are also stabilizing. Their documentation is also getting stabilized slowly. Okay. So it is a pain, right? It took 2 days for me to actually set this up and make it work. Make the GPU thing work. Right? Now I started working on the model, and now I'll show you the problem with the model. Okay. Are we good? Did you get what I'm actually trying to say or explain?
Yes.
I'll
Yes,
start
sir.
this. Let me show you the slide first, and then I'll talk about the problem. The problem in the sense, the implementation, right? There are two things, right? So here we need to build a network that actually encodes 128 pixel thing, and there is a network that actually, this is just an architecture. This is just an architecture. We construct this. We actually build. We actually write code to get this structure, and then use this structure in a deep learning model where these embeddings will be created. This is one way of doing it. Okay, as a binary classifier, face recognition as a binary classifier is one way of creating the 128 dimensional vector. Right here, the cast function we are using, normal categorical cross entropy. In this code, right, I should have used the categorical cross entropy as the loss function. Okay, I forgot the. Give me one second. I think binary cross entropy. Yeah, binary cross. Yes. So binary cross entropy here. Where is it? Where is it?
Bit above, sir.
Yeah. I removed it, right? Hmm. So that's how I would have done. Okay. This architecture should have had a cast function, a categorical cross entropy. But what about this Siamese network? What about the Siamese network? In this, right? I'm saying, right, in the code I wrote is not a Siamese network. That's what I'm trying to say. So why is this not Siamese network? Can you tell me? Even when I use a triplet, whatever the class, it is not Siamese network. Can you tell me? If you look at the cast function of the Siamese network, what am I doing? Calculating Euclidean distance between anchor tag and positive, anchor tag and negative. But if you look at this code, is there a way that I can actually pass anchor tag and positive and negative at once? 3 inputs. See this Euclidean distance, whatever I am calculating here, am I passing 3 inputs or 2 inputs? Are you guys understanding what I'm actually talking about?
To
Two, right?
Two only, one at a time, right?
Yeah.
Anchors.
One anchor and either positive or negative I am passing. In this case, will I be able to do this calculation? This whole calculation, can I do that? If I have to do this whole calculation, what should I do?
We need to pass both positive and negative.
Positive, negative, and anchor. Three inputs I have to pass.
Yeah.
So this function, this implementation is not right. So I need to, actually we need to build a code that actually takes three inputs, and then we need to calculate that particular whatever, and output we need to think again, right? Here in this network, we are actually trying to do a classification thing, right? Either target variable is either 1 or 0. But if you take three inputs, right, what's going to be the output? Anchor tag, positive and negative, both you have taken. There are three pictures. Anchor picture, positive picture, and negative picture. Three inputs are there. What is the y variable?
0 or 1.
0 or 1, how 0 or 1? When you are passing three inputs, your goal is what? Your goal is to, for every record, I think you should have 1 only, not 0. Right? Your goal is,
Anchor positive is 0, 0, right? Anchor negative is 0, anchor positive is 1. Is that not right?
no, right? Here, right? Don't take that data set into consideration. The previous data set, right? This is one way of doing it. This is another way of doing it. I think I mixed it up and confused, right? I got confused and I'm confused.
Sir, what I'm here in this slide, you are showing an equation, right? Fp minus fp plus alpha is greater than or equal to, less than or equal to fp minus fn. So maybe the y or the y may be 1 or 0 based on this equation truth value. If this is true, if it is satisfied, it may be we may get y equal to 1. If it is not satisfied, we may get y equal to 0. I'm just thinking, I'm making a guess.
Yeah, that's what. Even I am thinking now, right? I have found a GitHub URL where the code is implemented. I will show you. But I am thinking. I am also thinking. See, I made two mistakes, and I'm one in that word embeddings for SVD. The second is this one. So I'm actually correcting them now. Live I am actually correcting in the class. So I'm actually thinking, and I want you to think along. But that's not going to be the way, sir, because it should be like this only, right? Anchor and positive's distance should be less than anchor and negative only, right? All the time. I think we should generate one. For every record, we should generate one. Target variable is going to be one only.
If a new record or when I say new record, or maybe if we need to validate any new record of an existing person, then if this is satisfied, then we can say that yes, he belongs to that database or he's an existing employee from that.
The point here is, for any person, we are trying to generate this 128 pixel, 128 dimensional vector. That's our goal, right?
Okay, sir. Okay.
Right? We are not validating anything. We are not classifying anything. Okay. Ultimately, this network should understand how to generate this 128 dimensional vector for a picture.
Yeah. Okay.
So in that case, right, for every record, you should put 1 as the target variable. Target value is going to be 1 for every record. Cast function is going to be this one. Instead of passing 2, we will pass 3. Right here, I'll have positive Siamese net, negative Siamese net also, and then instead of Euclidean distance, I'll have some other, whatever, and binary class entropy. I can give, right. I can actually not even binary class entropy. That guy actually did another unit cast function, something he did. Let me show you that. Now, yesterday I was actually, for last 2 days I am working on this. This is involved in very heavily time involving tasks these are. That's where I was unable to do it, even though theoretically I have some understanding, right? So this is the, so this, when this batch is going on, right, I think you guys are showing interest and thinking along. That's where I am actually spending time. If somebody doesn't care, right, I'll also don't care. I just go along, right? And then see this identity loss he created, right? Identity loss is y predicted mean. That's it. This is not even binary cross entropy. Binary cross entropy is what? Minus y log h of x minus 1 minus y log h of h of x, right? Right?
Yes, sir, that's correct.
Yeah, here this guy, let me show you. For every record he took the y variable as 1. This code is very neat, and I was able to understand very clearly. So this guy get image. This code is going to get the image, and then get triplets, right? He is actually capturing anchor image, positive image, and negative image in this method, and generate triplets, right? He is actually generating triplets here. Triplets means, see this anchor, positive, negative, and label, right? What is the label here? See this np dot ones of batch size. Batch size, if you say 10, 10 ones will be generated, right? And 10 into 3, 30. For each record, there will be 3 images, 1 label, 3 images, 1 label, 3 images, 1 label, like that 30 records get created. For all of them, the y variable is going to be 1 only. Okay. So y variable is going to be 1. That means what?
Sir,
When
please
this,
come again, sir. The 30.
I'll come back and I'll come back. That means what? This function, right? This function is true. This function is true, right? This um, uh, the model should generate, model should, the model should generate this 128 dimensional vectors for 3 images in such a way that this function gets satisfied. Okay. So if you look at this, we are creating a data set, right? Generate triplets means we are creating a trained data set. Okay. For training data set, what you need? Input and output, right? Input and output, right? For training data set, input and output you need, right? Sisramgar.
Yes, yes.
Right? In our previous example, what we did? Pairs. See, this method is what is it doing? Make pairs. What is it doing? It's actually taking one anchor, positive, and label.
Yeah.
Or
One anchor, negative, and label.
or one anchor, negative, and label. Right here, because we have to implement triplet loss, we need anchor, positive, and negative, all 3, and label. Got it? Got it?
Yeah,
No?
just thinking how to.
Same and after pairs, we have created pairs and label. Here we are creating triplets and label. That's it.
No, every this AP and R 2-dimensional matrix, right?
3-dimensional. A is a 3-dimensional matrix. P is a
Yeah.
3-dimensional, and N is
Channels are also there. Okay.
channels are also there. I think it's not visible. And even here, right? If you see this one, see this?
Yeah.
This is like 224 by 3. Here you will get 3 and 323. See this? It is 1, 2, 3, 4, 5-dimensional matrix we are handling here. Got it? See, once you start coding, right, it is all becomes easy. You guys are thinking right. You guys, got things right. Especially when you ask question, right, that's when even I am thinking. You asked yesterday, right, when I was actually trying to show triplet class, right, you asked some question, which made me think, and then I thought, like, when you look at this cast function, it is not actually, it needs 3 of them, right? Anchor, positive, and negative. What am I doing? and then went in and tried to look for GitHub URLs for, see Siamese, network. So this is how you do even in real time. GitHub URLs, your problem, GitHub URL. That's how you need to search in the Google. You will find some GitHub URL which has, partial implementation or full implementation like this. Then you can take it and use. You cannot take whole thing and use it right there right away, because your pre-processing will differ. Right? Your pre-processing, your whole thing, if you don't understand, you'll not be able to do it. You have to understand. Okay, this is a generator, and this guy did while true. It's a generator, right? So it's going to give you, right, one batch at a time. Okay, so we can actually make it even better. I'll make it better. Okay, go ahead. Any questions?
Yeah, so the dimension of this yield, the APN is actually, let's say this is only returning one record at a time. Yeah, it actually returns one record at a time. So the
10, I think maybe, this guy, while list for batch size, this guy is appending APN, and then he is creating numpy arrays of APN. Right? For batch, this loop will run for batch.
Okay,
right?
for one batch, let's say batch size is 10.
10.
So the dimension of whatever this function returns is 10 by 3 by 224 by 224 by 3. Is that right?
Yes, Andy.
That is the input.
That's the input. The label is the output. For every record, label is one only. For every record, even though label is one, it works. Why? For every record, even though label is one, it works. Why? What is neural network trying to do? Neural network is actually trying to see this here. So generating 10 dimensional embedding finally. Where is the last? Here. So we are passing these three as input, and output is equal to a lambda layer of triplet loss. What is triplet loss is sending us back? No, it's actually calculating one number and giving us back, right? So until this number becomes one, we'll actually do this iterations. Right? This is actually the one, and the y variable is this is the triplet loss, and y variable is one. Right? Identity loss. Give me 1 second. Let me think a little bit. Output is this one, and then loss is a unit loss, right? Unit loss means this is the y cap, right? The outputs is the y cap, right? If you look at identity loss, y pred, right? Y pred is the this is the y pred. Our triplet loss is the y pred, right? Y pred is triplet loss. We are taking the mean of triplet loss, and we are trying to reduce that. What is this? Mean? Yes, we are trying to reduce that.
There are two functions, sir.
Yeah. Identity loss and loss, right?
Triplet loss.
Yeah. So the thing is, in this particular model, we are not looking into y and y cap, right? In general, in our normal neural networks, what we are doing, we are actually trying to compare y and y cap, right? We are trying to compare y and y cap. Is that right?
Yes, yes.
But here we are not doing that. If you look at this, this is input, this is output, right? Right. So when you run the model, what it will do, it will take the triplet and it will generate this, right? It will generate this. What is that? Triplet. Okay. Okay. That part is clear, right? So it is going to generate one number by taking the the anchor positive and negative embeddings. It will generate one number. Okay. Right. That one number we are taking and passing that as the loss. If you have 10 records passed, 10 batch, a batch of 10 records you pass, you will get 10 numbers here. We are passing that to identity loss. So what will happen in this identity loss? It will calculate mean of those 10 numbers. That may be, in the first iteration, it may be 100. What is the goal of the model? It will actually try to reduce that, that mean of the 10 batch. In the next iteration, it will calculate again the triplet loss. It will try to reduce that. Triplet loss, it will try to reduce that. Triplet loss, it will try to reduce that. So basically, the model is not dependent on y. That's where even if you take y is equal to 1 for all records, that's okay. Just to make the model work, it took y is equal to 1. That's it. But even y is not being passed here. Inputs only we are passing. Y value is not passed. No. While training will pass. Sorry. While training. Here, in the generator, right, we have y label. Where is that? See this in the generator, right? This generator has got label. So the model needs the TensorFlow model needs y variable. That's where we kept 1 as the y variable, but we are not using y while training. Got it? The architecture is in such a way that it is not at all not looking at the y value. It is looking at the loss and trying to triplet loss and trying to reduce that triplet loss and trying to. It is calculating triplet loss as the output and trying to focus on that only to reduce. Output, reduce. Output, reduce. Got it?
Yes, sir. Can you please go up a bit? Maybe the y is used in one of these functions.
This one.
Yeah, this data is actually sent while fitting, right? While training.
Yeah, yes, Sandy.
The below is all the definitions. Identity, all these are definitions, and we are passing, and we are creating the objects of whatever the classes are. So
yes, Sandy.
when fit is actually called, all these being utilized, right? All this embedded model.
This is the model. This is the model, actual model. This is
Yeah.
the embedding generating model. 10-dimensional embedding this guy is generating, not 128 dimensional. The final layer has got 10, right? Not 128.
Okay.
So understanding this is a bit complex because I was actually looking into this for 2 days, and this is actually a new finding by me, right? I was in an impression that we should always have y variable, and I can calculate cost using y and y cap only. But this is a new way, right? Don't know whether you got this point or not, but here you have the whole thing. We are not looking at y. We just kept y is equal to 1 just to make the TensorFlow satisfied. While training, it needs y. So in the generator, we are passing x and y. That's it. But we are not using x and y. This is actual Siamese network. I'll implement this. I'll implement this today.
Actually, sir, I was thinking that y value might have been used in one of these loss function, triplet loss, or the identity loss.
No, nowhere it is used. See the code.
Yeah,
Identity loss, mean of y cap, right? Y pred, right?
y
That
true
is
is also there, no, sir. Y true.
Y true is there, but we are not using it in here.
Okay.
And that's a we'll analyze. Your questions are right. Just behold and try to ask questions here. Right? This is identity loss, right? This is identity loss. and we are saying ypred. What is ypred? This output is the ypred, right?
Yeah, triplet class.
Output is the ypred. What is the output? Triplet class. We are taking triplet class as the identity class or the last function for the model. We compiled last function, we said identity class. So model will focus on this to reduce. You know, Adam layer will try to reduce that. But no, is this a convex function or not? That also we have to see, right? This identity loss should be a convex function, right? So the y prediction is what? Let us look at that. If the y prediction is a convex one, mean should also be a convex one, something like that, right? So we should think like that. So anchor positive and negative. What are these? Anchor positive and negative is equal to x. What are these? Triplet class. So they are the inputs, right? Anchor positive and negative are the inputs. Or base model's output. What is base model? So compile, compile model, base model I am passing. If you see somewhere here, see compile model, base model is nothing but embedding model. This is the model. Right? This is the model we are passing. Right? We are passing to triplet class function. Right? Triplet class function is taking the outcome, right? 10-dimensional vectors here. They are the outcome of anchor, outcome of positive, outcome of negative. Maybe first iteration they are random. Okay, this is a kind of unpacking in tuples unpacking kind of thing. Okay, distance between anchor and positive it is taken. Distance between anchor and negative, and we summed it. Right, this is actually not a Euclidean. If you apply square root, that becomes Euclidean, but square root is not applied. That's okay, I think. And then basic class is equal to positive distance minus negative distance plus alpha. Positive distance minus negative distance plus alpha. This must be less than or equal to 0. Okay. So we take a maximum of, so the last function is like this. Maximum of this plus 0, comma 0. Now, if it is less than 0, right, you will get 0. If it is greater than 0, you will get some number. So some number is there. That means the model should work to reduce the cost. Right? These are square functions, right? Square functions means they are convex only. Okay, we took two square functions and we are trying to do something here, right? And then we are taking maximum of it. But one of these, I think it is convex. No, I'm not thinking more much there. Like k dot maximum of whatever, right? This is the last we are sending that. Got it?
Yes, sir.
So nowhere we are using y. Y true is not used anywhere while calculating the loss or cost of the model. Okay.
So that means identity loss. If you remove that input parameter, also it should work, right? Identity loss
So
has
y
two
true,
parameters.
even if you remove that, should work, but maybe loss function generally sends both. If you do take out this, right, it may throw error saying that expected 2 parameters and 1 is there, something like that.
Yeah.
The structure, right, the existing signature, method signature, it is actually trying to satisfy function signature. I don't know whether I think you guys are getting it, right? But this is, I like it, I am finding problems and I am solving them. I like it. Okay.
This is actually a bit clear, sir, today.
This is clear, and you're actually pointing it out, and you're unable to articulate it. Maybe yesterday, day before yesterday. Maybe you are looking at the cost function and you're not finding the same thing in the model, right? Maybe you kind of, these are, I actually explained two different concepts mixed up. This is a different concept, and this is a different concept, I think, right? So this is one way of doing it. This is another way of doing it. Triplet class way is one, and classification way is other. So I implemented this, not this. So when you are asking, right, I was thinking, but I couldn't. Yesterday, day before yesterday, I don't even know that I am doing mistake. Yesterday evening, I was actually thinking about the last function. Right, I used a triplet class, some pre-built method, right? Pre-built function, and in that it is not taking the outcome from the network, the 128 dimensional vectors. And even if you pass 128 dimensional vectors, it should actually pass 3. Then I kind of looked into the internet and I found this. Okay, so I'll implement this, whole thing I'll implement and try to send. I'm trying to work with a bigger data set also. I am working on this because I had to deliver it to one of the clients. We promised them that we'll give a POC. That's another reason. Okay, sorry that I am telling you truth, but yeah, basically your questions and my task actually made me do this. But this is good, I got to know a new thing. It is always not that you depend on y and y cap. You can actually do things by just taking the input, and it is like unsupervised, it is, right? Are you getting it? We are not really dependent on y variable. We are actually taking input only and trying to do something. This is kind of unsupervised, it looks like to me, right? But systematic. Do you agree?
Yes, sir, that's correct.
Sir, Giri garu, Narayana garu, any questions, concerns? Still trying to understand?
Yes, sir. Still, I'm trying to understand, sir.
Yeah.
I think it will take time for me.
Yeah, it will take time, and I'll implement our code and upload it into the drive. Try to look at it even after
Yeah,
1 month or 2 months, right? Let me know if you need help, right? I'll help.
okay,
Yeah.
sir.
So
Sure.
this level of understanding and the way we can do, right? We can solve many problems in the industry. No, unfortunate that industry, many people doesn't know. Even I don't know, right? I am actually in this area for last 6 months, 6 years, right? And last 3 years is very intense, basically. But now I got to know this. So that's how it is. The field is like that. There are new things and existing things. You need to spend time. You need to sit it, peacefully and think and try to do it. It's not going to happen in a hurry. People generally think like Java, .NET kind of technology. It is no. It is not a technology. This has got applications in all industries, all areas. No matter what, you can apply AI. So it's a very very broader area, and you need to have a peace of mind and research kind of thought process rather than you know delivery. Right? People are always in hurry to delivery. Right? The delivery is, there is research in these projects. So why am I trying to explain this is, to client you should educate. Right? This is how much I can do. This is how much the research is there. This will take time. Right? These three are the approaches. We should be choosing the best of these three. Right? These two. Something like that. We should be educating the client all the time. This is not the old case of delivery. You take a requirement. You have the struts or Spring or a database MySQL. You just create table. You just finish it. There is a stipulated time you can do. No, even when there are pre-built models, you have to do more research and do, right? So this is one classic example, and this is extreme. I think what we are doing here is extreme. Okay, so I'll implement and upload today, definitely. By maybe 1 o'clock I'll try to do that. That is one good thing I did yesterday. I'm happy that I'm correcting my mistakes. Unfortunate that in the class I am correcting it, but that's fine. I think as long as you understand, that's fine. Okay, so I'm going to move on and start a new topic here. So I think we are almost done with the word embedding. Yeah, there is one concept, theoretically Theoretically, in 2 minutes, I can explain. Okay. Did we do this? No, right? So this CNN model, one-dimensional CNN, one-dimensional convolution, we did not do, right? This implementation I didn't show you, right? Yesterday, I was just theoretically talking about it, right?
Yes, sir. We were talking about it.
Yeah, yeah. So the end of machine learning. That's what I'm actually trying to explain. Once you have embeddings of the pictures and the text, that's the end of machine learning. Deep learning is the solution. There is no other way you can solve the problems efficiently. You should have huge volume of data, or you should have a pre-trained model that will have weights already understood, like VGG16 or ResNet 50. They have trained weights, and you can use those trained weights and take the less data and work on it, or you should have huge volume of data. So the major reason AML came in and is getting popular because it can handle unstructured data. Once you take unstructured data, the data becomes multidimensional. Now, when you represent the unstructured data in numerical format, it becomes multidimensional. Example, word embeddings or word encodings, image embeddings or image encodings, right? When you take one image and encode it, it becomes a vector, and if you take one word and embed it, create embedding, it becomes a vector. Once it becomes a vector, right, your total document becomes a two-dimensional array. Total data set or batch becomes a three-dimensional array. When you have a this kind of array, right, you should definitely use deep learning. And especially for text, one-dimensional convolution is better because it works like n-gram model. You can do literally 10-gram model, 20-gram model. Yesterday I explained. Do you want more clarity on that? N-gram model, how one-dimensional convolution does? Should I explain it again? Yes, no? Okay, no need, right? So one-dimensional convolution basically applies convolution there. When I say convolution, the outcome is going to be one number. It multiplies this number with this number, this number with this number, this number with this number, like that, and then sums all the multiplications, linear combination, and generates one number. So it slides here, it slides here, it slides here, like that. Okay, and the formula is same: n minus f plus 1, n plus 2p minus f plus n minus n plus 2p minus f divided by s plus 1. That's the formula of the dimensionality it reduces. Okay, it actually does the sliding window in one direction only, row direction only it does. In 2D convolution it does in two directions. In 3D convolution it does in three directions, right? Rows, columns, and depth also. Okay, so that is 1D, 2D, and 3D. I never used 3D. Somehow I didn't get a chance to work on that kind of data set. Okay, so once after doing that, you can actually do pooling. So here I am applying two filters of the same dimension. You can do that, right? Generally we do that. If you do that, right, what happens? The outcome is going to be, for this particular one document, you will get two vectors, right? This is like filter size is 2, right? And columns you don't care. Rows 1521. I said just take this as rows. 1, 2, 3, 4, 5, 6 rows, and you applied two-dimensional filter. One-dimensional filter with 2 as the filter size. Then the outcome is going to be 6 minus 2 plus 1, 4 plus 1, 5. 5 by 1 is going to be the output. 5 rows and 1 column. Got it? Should I write or getting it? Should I write?
Yes, sir. Please, sir.
My voice is clear, right? Today my mic did not connect properly.
It's pretty clear, sir.
Okay.
No disturbance at all.
Okay. Yeah, it connected now. It did not connect properly. Oh my god. Yes. Sharing? Yes. I don't know, the paid fee, that's good for me, but actually most of the people are disappeared, right? Have disappeared. This is what happens in every batch. So let it happen. What is my problem? Yes, it is my problem. Somebody knows the technology well, right? It's going to help me, right? Help me in doing projects. What is this? Give me one second. Oh, I don't have the software. Sorry. Give me 1 second, okay? So if we want to do lots of things in AI, exciting things in AI, we should definitely know Ubuntu, Unix, Linux. Okay, Ubuntu is the best because all these deep learning frameworks actually support Ubuntu and they give instructions to work with. Okay, so definitely one must know Ubuntu. Windows will not work. Mac definitely will not work. Mac machine, if somebody has Mac machine, right, it's waste. TensorFlow 2.4 will not work on Mac because the GPU that software is there, right? That CUDA, CUDNN, and NVIDIA drivers. Those all things will not work on Mac. Okay. Windows, you need to install VC++ and all, and it is a pain. It's a really a painful thing. And if you have to migrate it to the server, right? Anyway, use Unix server only, no Windows servers. So you cannot migrate it. Definitely, you should know Unix. You should know definitely. It is a very simple thing. Ubuntu, there is a lot of community, and you can easily use it. Okay. So here, what I said, this one-dimensional community. There are two filters here, right? I am taking first filter and trying to apply it. Let me take another color. If I apply it like that, what happens? I'll get one number, right? Number n1, I will say, right? If I apply filter there, I'll get another number n2, right? What the heck? If I apply another filter there, one document I am applying on n3, n4, n5, right? 5 numbers I got. This part is clear. This part is clear.
Yes, sir.
Yes, yes.
Right. So that's what I calculated. It is n minus f plus 1 is the formula to know how many numbers you get. There are 6 rows here. 1, 2, 3, 4, 5, 6. And there are the filter size is 2, right? Filter dimensionality is 1 and 2, right? 6 minus 2 plus 1 is 5, right? If you apply one filter, you got this. If you apply second filter also, you will get 5 more numbers like that. It's going to be 5 by, sorry, it's going to be 2 by 5 by 1. A 5 by 1 dimensional matrix with 2 because you applied 2 filters. If you apply 10 filters, right, are 5 by 1 by 2 depth it is, right? If you apply 10 filters, it is going to be 5 by 1 by 10, like that it's going to be, right? For each document, you will get a this kind of a whatever, and you can apply pooling again. If you take 2 as the pooling, right? One dimensional pooling is also there. It takes 2 takes the maximum, right? You will get maybe P1, again maximum P2, maximum P3, maximum P4. Here also the same formula, n minus f plus 1. N is what? 5 minus pooling is 2 plus 1 is 3 plus 1 is 4. 1, 2, 3, 4. P1, P2, P3, P4. Right? That's the ultimate thing, right? And again on the back arrow also you will get P1, P2, P3, P4. So now you can actually flatten this or whatever and then apply a dense layer. That's how you do. So this is like 2-gram model. 2-gram model. You are considering 2 grams at a time. 2 grams at a time. Why am I saying 2 grams? This vector belongs to one word, word 1. This vector belongs to word 2. This vector belongs to word 3. This vector belongs to word 4. This vector belongs to word 5. Like that. Okay? Got it?
Yes, sir.
Yeah, yes, sir.
Now,
So there are two filters, right? So
yeah.
this one-dimensional vector n1 to n5
Yes, sir.
is an output for one filter. So when
Ah,
the two filters are applied, it will be a
two
matrix of two vectors, right?
Yes, sir. Yes, Andy. Yes, it's a 3-dimensional vector of
Vector.
two, 1 column, 5-row vectors, matrices.
Yeah, that will be 3 dimension. But if this is for only one record, so if
Yes,
if there are 4 records, that dimension will change to 4 dimension.
yes, Andy.
Four,
Yes,
4 into 2 into 5 into 1.
yes, Andy. Yes. In the image processing also the same thing happened,
Yes, that's correct.
but we are actually kind of understanding now, or it's getting better now. If you have
Yeah,
thought
that's
process,
correct, sir.
yeah, if you have the thought process right, maybe dimensions are wrong, numbers are wrong, that's okay, we can fix it, right? That will get it, right? Concepts are right, someday we'll get it fixed, when we think we'll get fixed, when we actually sit and try to do something. So this whole knowledge is needed to do real-time projects. I will not involve people in projects because they don't understand, right? Even if when I try to explain something and just do this, they'll not understand why to take them, right? So that's where we'll not involve people in projects. But if somebody is there like you who are understanding, or ready to spend time, right? Then it is useful for you and me both. Rather, it's a waste of time, right? You sitting there, I sitting there, and it's a waste of time. Okay. Initially, people ask for projects, and once we are into the real thing, right? Nobody shows interest. That's kind of the pattern I am seeing for last 3 years. That will change even now, and especially the students, right? The college students are not coming at all. They want everything free, and on top of it, they don't want to spend time. And there is a huge requirement in the industry. You believe it or not, I know 4 companies. They're looking for people. At least at least 8 to 10 people are needed now. No people, no, nobody is there. That's a huge business. If people sit there and understand and do what I say, it'll be business for me. I don't know that's going to give life to somebody, but it's a business for me, right? I don't know when this problem will get solved. I don't even know. So let us look at an example, a code example of one-dimensional convolution. So Wasim dataset, Gensim, yeah. So this is actually one project we were working on, right? This is one project in the sense there is a researcher called as Ramaraju, and we were actually trying to help him. He's a professor in one of the colleges, and I know he requested me to help. I was actually trying to help him. In that process, I worked on this. but this data set is not that clean and good, and it's not huge also. So we didn't get good results on this. But as an example, to convert text into vectors and then apply one-dimensional convolution and two-dimensional whatever the dense layer, I'll show you. So I have taken this data set, right, and did some cleanup, right, and then splitted the data into train test. That's the first thing we have to do, right, and then kind of used a deep learning TensorFlow module to tokenize, and then fitted on the tokenization, this tokenization object. I fitted on the X train so that it understands the words and gives each word a number. Okay, so that is there, and then we are going to create embeddings for these words. Give me 1 second. So that's I don't know where I used. Give me 1 second. So I have taken these words here and created a corpus and passed it to GenSim. I commented this because every time I execute it, may actually generate it again. Okay, and then I trained it here, the word to vec and embedding dimensions and 150 dimensional vector I am generating for each word. I am generating 150 dimensional vector, and here I am generating batches. Okay, I'm actually trying to get the word to vec embedding for the word. So I pass list of a sentence, right? A sentence I pass here, and then from the word to vec model, I am trying to get the embedding, right? Word to vec dot vw of word will give you vector 150 dimensional vector. I'm putting it. So here I am actually creating a two-dimensional array. This two-dimensional array I am creating, right? First row, first words embedding, second row, second words embedding, third row, third words embedding, like that. See that we are creating a matrix there, two-dimensional matrix, and we are populating the words embeddings one after the other in a loop for that sentence. Okay, if you see this here, embedding dimensions is the columns and maximum length is the row. So I said in one of the classes, I said that I need to create 1521 rows and 150 columns, because the maximum length, the maximum lengthed sentence in this corpus, in this data set, is 1521. So I have created a zeros matrix, two-dimensional matrix upfront with 1521 rows, all zeros. 1521 rows and 150 columns, all zeros. I created this matrix, and then I am filling the rows where I have the sentences, right? If not, right, else statement is not needed here, I think. Yeah, else statement is not needed because already zeros are there, right? Until the sentence words are there, I am going to fill them. If they are not there, I think I can comment this out. I think understood this code. You can write it, but understood, right? Understood?
Yes, sir.
Yes, sir.
It's a simple thing. We are actually converting text into word vector representation, and then as part of as a result, right, the sentence one row becomes a two-dimensional matrix. Now here I am actually creating batches. Okay, I took batch size and now I am actually creating a three-dimensional array, right? I created a two-dimensional array and then putting that into an array. If the x batch is null, right? X batch is the here. X batch is none. Then I am creating a new three-dimensional array. If not, I am appending the x batch to the this new array I am appending, right? So I am actually creating a batch. This batch I am creating here. Okay, whatever batch size I say, it's going to create here. Now I have methods to actually do that. Whatever. So here in TensorFlow we have data set, a class that actually has from generator, which actually creates the split batch. We have seen data generator, a class that is actually taking from file, right? But here you cannot convert everything into, every sentence into a two-dimensional matrix and keep it in memory, because if you have 10,000 documents, each document is of size 100 pages, right? You can imagine, right? Each document is of maybe 10,000 words. Then it's going to be a 10,000 by 150 dimensional vector each document. Getting it? Suppose that 500. Yeah. Let me reframe the statement. There are 10,000 documents. In each document there are 1,500 distinct words. Suppose that. Okay. Then in each document, when you convert into the word to vec, right? What happens? 500 by 150. If the embedding size is 150, it's going to become 500 by 150, right? Each document becomes 500 by 150 dimensional matrix. Do you understand?
Yes, that's correct.
Right? And then there are 10,000 of them. It's going to be too huge, because 500 by 150, let me calculate that. So memory is not going to be sufficient. So in RAM you cannot do that. So let me 500 into 150 into, if it is a float number is 32 bit, right? Divided by 1024 is what? Megabytes, right?
So
Divided
these are all
by 8.
bits, no, sir?
Divided by 8 I should do.
Yeah.
Divided by 8 divided by 1024 is going to be kilobytes.
Yes.
Divided by 1024 is going to be megabytes. Divided by 1024 is going to be gigabytes. Okay, into 10,000. Right, 10,000 documents are there. Each document is going to come as this much gigabyte. Right, when you have 10,000 documents of them, it's going to be 2.79 GB. Right, 2.79 GB. Right, so if you have 32 GB RAM or 64 GB RAM, that's okay. But if you have 8 GB RAM, right? If your data is like this much size, the data you kept everything in, you converted everything and kept into memory, it's going to occupy lots of space. So I created yield here, a generator here. Right? What it does, on the fly you pass the sentence. X is going to be sentences. You pass the sentence, it actually calls the the word vector and then creates a three-dimensional array of the batch. If the batch size is 4, it's going to create a batch like this and return, and return it. Okay. While writing this code, I created these diagrams, so they're kind of in sync. Okay. So this from generator class will take a lambda, will take a function to generate the data, and you need to specify the output type and output shape. Right? Output of the generator. Okay. Output of the generator you should explain. TF float and TF int. No, this is the byte range is going to be int. This is going to be float 32 matrix, an array of matrix, and output shape, batch size, max length, and embedding size. Max length is what? 1521. Okay, and the y variable also you should specify. I specified none here because it's a one-dimensional array. Okay, the byte range is going to be one-dimensional array. So the data set has got many methods are there. I'll show tomorrow. There are other methods are there. I'll show tomorrow. TensorFlow data set has got other methods. Right? From generator is one important one. It actually for the test set and train set, you can after building a model. Here I took one-dimensional convolution. I'll explain that later. So in the model, right, you actually when you fit train data set, you said here. What is train data set? It's a TF data set generator, which will actually generate batches of the size you specify. I think I've given a constant here. Batch size is train batch size. I gave whole data. Okay, you can give less data also, but I gave
That's the buffer size.
buffer size it is. Okay, okay.
Train
Batch
batch
size,
size might be somewhere.
yeah, 64.
Yeah, 64.
Yeah. So somewhere here I'm using, while splitting the data, I'm using batch size. That's where, I used it there. And, that's how it's going to generate 64 records and then pass it to this network. See this network, one-dimensional convolution, kernel size 9, I said. It's a 9-gram model. 9 grams. 9 word vectors it will consider. No, the size is 1521. 9 vectors. 9 vectors it will consider and consolidate it to one number. Again, next 9, one number. Next 9, one number, like that. Okay. And then pooling. On top of it, right, it will try to consider max pooling of 5 numbers. Let's try one. Filters 16. I've taken 16 filters of 9 size. Okay, and then 7 and 8 filters and 5 like that, and then flattened it. Dense layer, dropout, dense layer 1 I am generating. It's a sigmoid function, either 0 or 1, because the data set is trying to, the problem we are trying to solve is, whether a tweet is a bullying tweet or non-bullying tweet. Okay, the rest of the story is same. Binary class entropy, and then there are some callback methods, and I was getting around 60-70% accuracy. The model was not working well, and in TensorFlow, right, when you actually fit, there's going to be a method called as history. So if you fit right, you get a method called as the object called as history. You can use that history object to plot. If you say, right, history object dot history of metric, right, val metric, right, whatever, right, so you can actually plot how the the accuracies are actually moving. You can understand. Okay, so that's a one-dimensional convolution, a convolutional neural network on a text data. Okay, convolutional neural network on text data. Got it?
Yes, sir. I remember we discussed kernel size when we are discussing about the CNN. Can you please brief me what this kernel size is?
Kernel size is the dimensionality of the, this. Let me show you in the diagram. So this is the kernel size. If I say 9, right, 9 rows will be there. Number of columns will be predefined, because on a one-dimensional convolution, the input columns are the number of columns in the filter.
Yeah, in 2-dimensional, if you say kernel size equal to 3, it will be a 3 by 3 matrix.
3 by 3, and channels is going to be prefixed.
Channels will come. Yeah.
So this is here columns are prefixed and there channels are prefixed.
So if we say 9, this
9
will be
rows.
9.
9 rows and 150 columns. This filter is 2.
Yeah, okay.
2 rows and 1, 2, 3, 4, 5 columns, because 5 columns are there in the document.
Okay, 5, yeah. It's a kind
5
of
will,
row vector for your
yeah,
word.
5 will be automatically taken. Yeah. Okay.
Yeah.
So that's it for today. Yesterday I uploaded, right? Did you find it?